Hi, I'm Hannes. I'm from Portland, Oregon, the coffee city. Normally, I like to drink my coffee as a latte, double shot. But right now, I take a little break from it and I switch to great tea.
I got a ton of takeaways from this conversation. First one has to be hands down data hygiene, man. Like the importance of data hygiene and how Hannes was able to map out what good data hygiene looks like, not only from the machine learning perspective, but also from just like the software engineering perspective, from a design perspective, from the backend engineering, all the way data engineers, everything. That was mind blowing to me. I loved it. What about you? And who are we talking to, by the way? I didn't even say Hannes's name and what he does and where he's working.
All right, I'll get into that. I'll get into that. I'll give the intro and then I'll give my takeaway. So, Hannes Hapke, first off, awesome guy, incredible guy. He's the first ML engineer at Digits, where they are building financial tools for the future. I mean, really, you guys gotta listen to this episode and hear about it. And at Digits, he started and sort of laid the foundation for their MLOps approach and their machine learning approach as a company. He, prior to Digits, has worked in a number of industries, including retail, healthcare, and ERP companies. And he's actually the co-author of 2 machine learning books, one of which we talked a lot about, Building Machine Learning Pipelines, which is published by O'Reilly. You should go check it out. And the second being NLP in Action from Manning. So that's Hannes, incredibly impressive guy. And I really, really, really enjoyed 2 takeaways, I'll say. Number one, I loved his point about how thoughtful design supercharges machine learning and vice versa. It's such an interesting point that honestly, it's the first time that we've had someone on the podcast in like 100 episodes come on and say that.
Yeah.
And then the second takeaway that I had was really right around the 21-minute mark. Hannes walks through the entirety of their machine learning pipeline and how they implemented it and like what all the elements are, what the alerting looks like, what the tooling looks like. And I'm like, if anybody is like building a machine learning system, they should just like cut that clip and like listen to it and like write sprint tickets based
Show their
off
team.
what you just write sprint tickets based on what he describes the features as. And you're like, okay, build alerting into Slack. Fine. All right. We're going to put that as a sprint ticket. I thought that was such a cool and like complete elucidation of like what a machine learning system was. So this was a great conversation. We specialize in great conversations.
Can you break down real fast what you mean by design superpowers or design supercharges machine learning?
Yeah. I mean, machine learning in a product is kind of a double-edged sword, right? Because it can make the product a lot more useful, but it depends on assumed and strictly defined behavior from users, right? Think about all of the ways that YouTube, for example, the ways YouTube's recommendation algorithms are gamed by unsavory actors like neo-Nazi groups and whatever. That's an example where like users are exploiting poor product design around the machine learning algorithm. But the other way is true as well, right? Like, you know, with other kinds of recommendation systems, like maybe TikToks or something like that, people find really great, thoughtful content because the way that the app is actually designed promotes effective use of the algorithm to find things that people really like. Now, it depends on the way you think about TikTok. I just use that as an example. I'm not saying it literally, but that's
I'm on TikTok now.
I know you are.
I'm waiting for you to stitch one of my videos. So I'll leave a link to that in the description in case anyone wants to come join me. I get like 5 watches per video, and I thought TikTok's algorithm was supposed to send stuff out. I guess my stuff isn't that good though. So come on, man, come and help me out.
Everyone's stressed somewhere. But yeah, that's to me how design and machine learning go together, right? They're really really a powerful pair when used effectively.
Well, yeah, I liked how he was talking about when they are thinking, basically the way that the design team and the machine learning team interact is fascinating to me. And it feels like they're really advanced in that way. And there's a lot of benefits from coming together and having multiple touch points and just talking about like having the design team being literate in machine learning stuff that they're doing, like, and how the machine learning team will sometimes go back and they'll teach the design team different concepts so that they understand what is possible. But then when he was talking about how they baked in explainability into the tool so that they wouldn't be getting as much garbage data, or that the end user could understand why they were getting certain recommendations. I thought that was awesome. It's just super cool to see. I mean, he goes into so much detail and he's so transparent about how and why
For
they
sure.
did everything. I thought this was awesome because of that. Like, it's rare. I feel like people are so open when they come
Yeah.
on here, and he was very much from the get-go like, these things need to be talked about, we need to be addressing these problems, and I want to help get the word out about it. So Hannes might have won like my favorite human of the year award.
He was great, and I think we should let the listeners get into it.
Let's do it. All right, dude, I think we have to start with your book. Like, give us a breakdown. How did you even decide to create such a beast? And like, tell us about that process and why.
Wow. I don't know about the term beast, but I think any technical book is a beast because like while you write the book, anything behind the scenes is changing, new versions are coming out, and you're like constantly rewriting chapters. So that qualifies it to make it a beast for every technical author. Why that book? It started out of the need of like having a concise end-to-end overview about like how to implement machine learning ops for companies. So like starting with like what is the data ingestion through the data validation, model training, model validation, and then the serving part. Back in the day, sort of like the serving part, like TensorFlow serving came out, and that sort of like they started to standardize the ways of how we deploy machine learning models. And then I think TensorFlow data validation came out, and we're sort of like there was a tool to analyze the data. Now we have like luckily we have more tools like Great Expectations and others. But what was missing was the glue code of like how do we connect all the different tools? There was like TensorFlow Transform came out at some point, but there was this piece missing between TensorFlow data validation, schema generation, and then TensorFlow Transform. And so the original goal of the book was like, how do we connect all those different pieces, and what would be, how would the pipeline look like? Well, then 1 year into writing this book, Google open sourced their internal TFX platform, basically the glue code between those different tools. And then I was in the scenario of like, let's rewrite this whole thing. And that's why we focused solely on TFX, because that was the platform at the time coming out. And I think it's for anybody who's interested in getting in the understanding of like, how can I put those pipelines together? How can I consistently train my machine learning models? I hope this book is a good introduction and an overview and a showcasing of like how to do this with one tool.
And how much have you thought about going back and rewriting it now after a few years? Like, or how do you fight the urge to not like have to update every edition every time you're like, oh man, now I wanna add that.
That thought came up maybe 30 minutes after we hit submit and we submitted the final draft to O'Reilly. There's like a time frame between you submit your final draft and then they do all the magic work behind the scenes until you actually get the hard copy. And I think Google released like a major minor version upgrade, like some cool feature landed, and I'm like, damn it. It would be so cool to add this feature. But at some point you just have to you have to stop because there, like some people saying like, hey, you're missing this component. Like I think the infra validation component landed after we submitted. It's such a cool component to test machine learning models before you actually release them into the wild. But if you continuously update the model, or update not the model but the book, then it's a moving target and it's really hard to get the book out. So sadly, with like printed copies, it's really hard to keep them to reduce the time frame between like last edit and the print. There's always a delta there.
Yeah, it makes complete sense. And I'm wondering, like, when you were thinking about writing the book, because there is some piece of it that you can abstract away and does not have to focus on the tooling, right? And then there is another piece of it where it is purely tooling and it's purely code. And like you said, it has to change as and like when TFX whatever 3.0 comes out, then now everything that we put in the code in the book is no longer valid. Or so like, what are in your mind some of those pieces that are the former, where it's like, or sorry, former latter, yeah, the parts that you can abstract away that are not the specific code snippets?
I think specifically for MLOps is sort of the thinking about how to go from raw data to a model and how to serve that model. I think regardless of what tool you use at the end, there is a mental workflow of like how you deal with your machine learning model and the corresponding data. For example, the concept of a metadata store. It doesn't matter what store you use or like what format or what orchestrator you use to orchestrate your machine learning pipelines. The fact is that you think about the orchestrator to coordinate your machine learning pipelines. The fact is that you think about like the metadata store, what's the value of setting up this infrastructure. I think those are the pieces I would love for the folks to take away from the book, that they maybe the specific tool we mentioned, maybe the version we pinned for this book is sort of like outdated, but the concepts and the sort of like the concepts and the mental thinking around like how do we actually structure machine learning ops in a company or for any large project. I would hope that this is a takeaway for the book. And just as a side note, we went back after the release and we updated all the example code to TFX 1.0 to the sort of like they have a pinned version, and so we support this. Unfortunately, it's not in the printed copy.
That I'm glad you guys got to do that. You guys got to do that and did that with the companion code for the book. One question I have: you pointed out this mental model of a pipeline, where you have to think about from the very raw files that are used as the source information, all the way to the model output. Like that the mental model there is a pipeline. And so I started off as a machine learning engineer, and I've been learning more about like traditional concepts in data engineering, right? Where in data engineering, I think a lot of this notion of like pipeline development, starting with cron jobs at Facebook in 2010, that literally, IPO'd. Everything was just a bunch of, shell commands and stuff. That I think data engineering really like got the whole software engineering industry thinking about this mental model of a pipeline or this design pattern of a pipeline. And I'm kind of curious, from your standpoint, like how did you weave into the book some of the concepts of data engineering that are really essential to doing machine learning engineering well? Like how did you approach that sort of crossover?
That's a really good question. I think when I started looking into machine learning operations, specifically coming from the data scientist world or from the machine learning world, I started really appreciating Apache Beam. Not fully understanding the concept at the beginning, but then sort of like when I unpeeled the onion, at every layer I got deeper and deeper, I felt like, wow, this isn't a magic tool. This is a magic tool. And to your point, it was like, this is probably today's version of the cron job. Everybody's using some sort of like a pipeline tool, Apache Beam, Airflow, whatever. But those tools are actually keeping the machine learning world, I guess, alive. Like that's what I would say. Like in the book itself, every TFX component is based on Apache Beam, and we stress in the book of like how can you write your custom components? How can you write like we only show like simple Beam code. I mean, I think that's out of the scope of the book to actually introduce or go beyond the introduction to Apache Beam. But if you want to write your own components and each component is sort of handling terabytes of data, like this is a good approach. Like think about the data in such a way that you can parallelize things. And to your point of like, maybe back in the day it was cron jobs, now it's Apache Beam. We use data flow at Digits. That's like, it's not just about training the model. I think training the model is actually, everybody has talked about this, like how can we design the architecture, and there's so much things around it which we need to set up and tune to actually get those pipelines to work. And a core part of that is like, how can we parallelize the data ingestion, the pre-processing, maybe towards an efficient training. So one thing I would also like for folks to take away from the book, and regardless of what tool you use, is like the pre-processing of the data is you benefit from this once you deal with like terabytes of data and you like shuffles through, like you run multiple iterations over your data. But then the big win there is like, if you take those graphs you generate from that pre-processing and you attach this to the later produced model, that is an ultimate solution against training serving skew. Like that's what we do at Digits. Like when we pre-process our data, we automatically generate a pre-processing graph. And then when we ship the model to production, we connect those two pieces, the pre-processing graph plus the trained model. And then all of a sudden, all the changes we make during our training run trickle through automatically to our production deployment.
I'm taking a second to process what you just said there. Dimitrios, you look like you have a question about that.
Yeah, I think that's a really interesting one that I hadn't heard before, like with this training serving skew, because that is something that comes up quite a bit. And I know that I've heard like a feature store, for example, is something that will combat that. But I hadn't heard of this pre-processing angle. And maybe can you just go a little bit deeper into how that looks?
Yeah, maybe an
for
example.
Sure. Yeah, totally. So is the typical example is like, let's say you have a feature you want to normalize, and you have some values in your maybe in your feature store or like in your raw data sets, and so you have a mean and a standard deviation given on that. So in your, let's say you use a pre-processing tool like TensorFlow Transform. The tool itself does two passes over the data. So it does one pass over the data to determine what's my mean, what's the standard deviation for this particular feature. And then it does another pass over the data to actually normalize those values. And so in that process, it generates a post-processing data set. That data set you can then use to retrain your models or to train your models. So in that case, every time you pull a batch, you don't have to process that data anymore. So that happens once. And if you iterate over the data set multiple times, you save some pre-processing time there. But the other cool benefit of that is you generate a graph based on all the pre-processing computation. So meaning that the graph contains of like, here's a raw value. How do you manipulate that raw value to get to the normalized version and that to the normalized value? And that is generated during the training process. And then when you deploy that machine learning model, that model receives the raw data. But before it actually hits the model for the prediction, it has to go through the pre-processing graph. So then you would, subtract the mean, do your normalization values or whatever you want to do in that moment. And that is a really good approach to like keep the training in sync with the serving. And if you use a machine learning pipeline, then this happens automatically. We don't even think about it anymore. So we have like, in our case at Digits, we pre-process our unstructured data in various ways. But if somebody makes a change to the pre-processing step, that triggers a retraining of the model, that triggers a redeploy of the model, and that change goes out hand in hand. I had this happening in the past. I was working with another data scientist. I was responsible for the machine learning ops. The data scientist was responsible for the model itself. We had a little glitch in the communication. I forgot to mention that. I was like, oh, I changed the embeddings generation here. And then all of a sudden we deployed the model, saw one garbage for a couple of days, or we saw the garbage immediately, but it took a couple of days to actually figure out what happened here. And then after a week, we realized that, that pre-processing is out of sync from the internal of the model. So, and if you go by connecting those pieces, you basically prevent those scenarios from the get-go.
I think this step of machine learning engineering around curating your data structuring your data, and applying the same software engineering precision that you do to model training, to data pre-processing. It's something that we're not just starting to emphasize in industry applications like yours. It's also something I'm starting to see in the actual education of ML engineers now. So, for example, in the full stack deep learning course that's running right now, I'm sure some of the people in the community and on this podcast are listening to it or are following along with that course. There's a big emphasis on like some of the data parallelism concepts that you talked about. Some of the emphasis on like ways to pre-process data, not just in terms of tricks to improve training, but ways that actually enable you to scale your machine learning system more effectively, right? And I think this is kind of what this is the concept that you're getting to there. The question I have is, I see your point about the pre-processing, and I see your point about how you involve it. What tools do you actually use? How do you actually use the continuous integration, continuous deployment? What kinds of testing do you have for the code itself to make sure that these changes happen in a continuous fashion and you don't need a lot of human involvement?
Yeah, very good question. I think you touched on a very important point. I think in the last couple of years, we made this transition to adopt a bunch of software engineering principles in the data science field. I don't know if that is what is the foundation now for MLOps. I hope more of those software concepts come into the whole data science environment or data science thinking. Like, I see luckily more tools to, for example, version notebooks. Initially, that's a really hard thing to do. Like, hey, you make a change in a notebook, and then it's hard to diff them. How does it look like in our site? So we try to remove humans as much as we can. So to walk through an example here, we have a pipeline set up. The pipeline has like a point to get the data from. So that could be like static files. In our case, it's like a BigQuery database. We have there's a statistics generation and a schema generation that happens automatically. We use TensorFlow Extended. That's a freebie we get from those components. We have the code for the transform. That is pure Python code. We have to use, in this case, to actually generate the graph, we use TensorFlow Ops for this. That allows us later on to combine those pre-processing graphs with the trained model. But it doesn't have to be the case. There's a new component coming out or has been released where you can use pandas to do the transformations. And that code can be tested. So you can have like pure unit tests and say like, okay, this is my raw data. This is my expected outcome of that transform function. The model training, we do some testing around that as well. Like, what do we expect from the architecture, the core pieces of the architecture? And then the model analysis, and that's sort of like highly standardized. Like you have a metric, you have your test data going in. That in itself is like is automated, and then we write custom components to go beyond this. Like for example, we have like qualitative data sets and quantitative data sets. We're running them against every model, and then we compare them against the last trained or deployed model and see the diff, and that generates a report for us. Showing what's the improvement in this case, and then we push this model into a registry. And when this happens, we get a message in Slack, say like, hey, here's a new model available. It's not deployed at this point, because then that's the one human touch point. A data scientist goes in, looks at all the reports we automatically generated, and does a check. Is it something we expected? Is it better? Is it worse? Does like a interpretation of those results, and if that happens, then we make another commit. I forgot to mention at the beginning, those pipeline runs are triggered through CI systems. So you have a bunch of trigger points. Like currently, you have to make a commit to a repo, so that is all code reviewed to actually trigger the pipeline itself. We're looking into automatically triggering this once we have X number of new samples reviewed from another data pipeline, but that's currently in development. But then once the model is produced and registered with a model registry, and the data scientist has looked at it, then we make another commit. and say like, okay, now we want to deploy this model. And in that case, the data scientist just confirms the model UID. Every model we generate gets automatically UID assigned, confirms its UID, confirms the configuration, but that's all in configuration file, commits this to a repo, and then we have a CI system, which is like figuring out, okay, what has changed, what version are we increasing, number of instances, machine types, etc., and then handles the deployment. So no human can deploy models like manually. Everything has to go through a code review system.
So I'm fascinated by how you've architected this and where you put the human check in, and why you ended up saying, all right, everything is going to be automated until it gets to this point where the data scientist is going to look at it. Like, how did you say, at this point is when we want the data scientist to go look at it, and if they say it's good, then it gets pushed out and everything gets put into its database, and it all gets that lineage that's tracked back to it. But it seems to me like there's only one touch point for a human in the loop, right? And why did you decide that one touch point is where it is?
I think it's this touch. It's at this point in time, because then we have the model fully trained, we have the model fully evaluated, and the reports generated to that extent that we can actually have a conversation about the model improvements. Like, we had a number of pipeline runs where we saw minor improvements, and we bailed on deploying that machine learning model. And then that's sort of like a group discussion. We said like, hey, we see here's an improvement of like less than 0.5% or something. Do we actually want to go through and spend the engineering efforts to backfill all our data? That has been also a process we massively improved over the last couple of weeks. And initially, it was always a big undertaking. So now the burden to get new models out is much less, but that's always sort of like in that moment, we can discuss the trade-off between, is it worthwhile to deploy this model, or potentially we even discover a model which performance is like decreasing, and then we're like, okay, we don't want to do this. But at no earlier point in time, we have all the reports available and like all the evaluations. And that is probably also the last moment before we would create, I don't want to say harm, but chaos and like maybe mess up some data. So that it's like, in my mind, it's like the ideal point. Like, we're ready to go, but like you're right before the rocket launch, but you bail on the rocket launch, basically.
I like that. So can you talk to us about the updates you did with the backfilling of the data and how you changed that? Like, what was the pre and post? What does that look like?
Yeah, so I think I have to, in digits, we do a little slightly different machine learning. Like in a typical like standard machine learning case where you do like classification models, right? You take every data record and you would run over the entire data set again and just like recompute everything. And in our particular case, and then maybe we need to talk a little bit like why is like this case a little bit different. We not just want to recompute everything. So we don't do pure classifications. We do like similarity machine learning. And so in that case, we have to take every record and then generate an embedding for this, and then recompute every embedding against all the other embeddings. Clearly, that doesn't scale for like a fast-growing startup. So in that case, those backfill processes, we had to make some tweaks to improve the speed up to recompute once we ship a new model version. And so a couple of things what we changed is like the way we generate those embeddings in the first place. That's something we highly parallelized. Back to your point, Vishnu, like making things parallelizable is like sort of that was the key there. And then when we compute nearest neighbors for our similarity assessments, we heavily optimized the way we find nearest neighbors for our transactions, or like find similar transactions for given transactions, and then the way we post-process that. So that was like a massive undertaking by the ML team the last couple of weeks, and all the improvements in that process trickled down to all the machine learning ops. So because that backfill process is now much easier and also fully automated, we can just basically register a new model in our registry. That down process system picks it up and then handles everything automatically, from like inferring all the embeddings and recomputing all the nearest neighbors.
So before we go further, I do want to take the opportunity to ask, for our listeners' benefit, what is it that Digits actually does? What's the product you guys build? What is it you do? And how'd you kind of get there?
Totally. Digits is on the mission to build like a new set of tools, or the next generation of finance tools. We're able to achieve this by like using machine learning left, right, and center. We have a number of machine learning models, and we sort of like summarize them as we call this like a living model. So what that means is like we ingest the books of small businesses, and then we empower accountants and the business owners through the insights from Digits. So normally when you're at a small business, you have an accountant, and the accountant comes in your books once a month, classifies them, and then gives you a P&L. But by the time the accountant actually takes a look at it, the books are already outdated, because you might have hired somebody else, or you might have had another major expense, and your P&L is not, they're always lagging, right? And so what we're doing at Digits is like making this real time. We look at the books, make a bunch of decisions, and working together with the accountants. I think that's really critical. Of like, it's not like we're replacing the accountant. It's like we're enabling the accountants to be faster and to make decisions in real time for the business owners. And that's something we do through machine learning. So we read the unstructured data we get from the banks or like their accounting platforms, ingest them, process them with machine learning, extract additional information, annotate the information, or like find similar transactions, suggest categories, suggest vendors, things like this, to make all the things which the accountants or the business owners need real-time accessible. So instead of waiting until the end of the month, you can go every hour and you get an updated view of like, how does your business look like right now?
I just think that, I mean, Demetrius, you're a small business owner. You've understood these kinds of tools. You tell me how you feel about it.
Well, I was laughing because I was like, oh, my brother is super lazy and he's an accountant. I got to tell him about this tool. He's going to love it. So
It is.
We have a tool, it's just called Digits Boost, and that is heavily using machine learning, because the accountants keep doing their work, but Digits Boost is basically watching them back. So it helps them save automating time. It helps them save time by automating their workflows. But at the same time, it's sort of like watching that back. So if they categorize something or assign a vendor to something, and we have machine learning models, they figure out, it's like, hey, this is looking odd. Like the 10 times in the past you said like, this should be, I don't know, Venmo, and now you're saying that this is PayPal. Then we send them a little notification, say like, hey, are you sure about this? Or we can go the other way around. Like they come in and it's like, hey, we think this is Venmo for you. And then they can just say, sure, I'll take that. So it's a perfect use case. I think it's a perfect use case for machine learning. It's a little bit an underrated use case, because everybody thinks about self-driving cars and cool computer vision tech. But every small company runs on an accounting books. Everybody has to do books. Otherwise they get in trouble with the local tax agencies, right? And perfect use case for machine learning. It does have an interesting twist. Every classification is highly subjective, and I think solving this with machine learning is super interesting, and I'm super excited and working on this problem.
I mean, first off, I just think it's such an interesting application. Like, as you said, like, you know, like cash management, accounting, like working for anybody who's worked at a startup, you know, right? Like the way that like, you know, and that's just one flavor of small business and it's high growth and whatever the heck else. But like for every business, there's all this like arcane stuff that goes into like how you actually manage your cash, think about finance, and it has an implication on everything, right? And so the idea of taking that and bringing it from, I don't know, like the mid 20th century of like accounting and the way that it worked with like, you know, what is it, credit on the left, debit on the right, something like that, I don't even know, to really applying, you know, advanced machine learning is it's super interesting. And I looked at the website for the company. I encourage everybody listening, check it out. It's a really, I feel like once you look at the website, which we'll put in the show notes, you'll get a much better understanding of like, wow, this really makes sense for why machine learning can be used to solve this problem. Now, with
And
that,
I think I love.
you go ahead.
I think
Demetrius.
that it's hilarious that now y'all are probably doing better than ever because of that bill that just got passed in the U.S. where they're going to hire whatever 80,000 new IRS.
$80 billion for the IRS
Yeah, that's it. $80 billion
to increase
for the
enforcement. So everybody go get digits and make sure you're not messing up.
Yeah.
And the digits is free, so you don't have to.
All right. Well, this is game
Dude,
over.
Where
Game
do I
over.
sign up?
Yeah. The question I had though is, you were the first ML engineer there. You were the first person to start implementing machine learning, or I'm so curious. Like, I've been the first data scientist, at my company right now. And so I have some understanding, but for a company that is so premised on the notion that like machine learning is, one element of our secret sauce, like, can you talk us through like what the first few months of your job were like? What kinds of things were priorities for you and how you spent day to day?
Yeah, I have to admit, I'm the first machine learning engineer and the first person who's like solely focused on machine learning. But I'm standing on the shoulder of giants. There's a team. There's an amazing team of engineers. They had been there for 2+ years. They developed amazing data engineering infrastructure that was already there when I arrived. So when I spoke to the founders, Jeff and Wayne, they said like, hey, now is the right time to do machine learning because we spent all the time to get the data in place. So in previous jobs, when I showed up, we talked a lot about machine learning, but then when I arrived, it was like, oh, we need to get the data in place. We need to clean the data. We need to do this and this and this and this. This was already in place. So there's like the team, the core team had previously founded and worked on Crashlytics. Crashlytics got bought by Twitter. Twitter sold this to Google. And so the core team had like a wealth of knowledge about how to do data engineering at the scale of Google and the scale of Twitter. So for me, like coming in as a machine learning engineer, I was like, ooh, this is the ideal place. And because like the data is in a really, really good shape. They have amazing data engineering principles. So I can come in and just put the tiny cherry on top of the amazing pie, like to really build like models. I can fully focus on building the models and building the infrastructure around how we keep those models updated, how we train them, how we actually use machine learning to the vast extent.
What does that look like when
Yeah.
a company has their data in good shape? Like, can you tell us what some of those green flags were as you came in and you were just like, whoa, this is really nice?
Yeah. I think it comes out in a couple of things. So you can ask questions around the data and somebody just like, hey, just write a query for this. It's right there. So it's not like, hey, it's in some unstructured text files and we need to parse them first and that sort of stuff. You have a team who is highly educated in terms of like how to process the data in a parallelized fashion. Like they were already using Apache Beam, Google Cloud, Dataflow for 2+ years. So there was like a whole wealth of knowledge I could tap into of like, how do we batch process something? How do we stream process things? So in that moment, we only had to build the connected pieces between the machine learning models and the existing pipelines already. So it's the pipelines were already in a good shape. They often had like basically models in place already who would do some work, what we then replaced with like deep learning models. Or that's always a good point of like, if you already have like a baseline model present, then it's a good moment to do like deep learning. Give it a shot. Like try out a fancy model and see, does it actually boost your accuracy rate? And in this case, when I showed up, they had already done all the statistical machine learning models, all the approaches that already happened. And in that case, I was like, okay, now I can actually bring in my expertise and like how to build deep learning models and how to build machine learning pipelines to keep them fresh and updated and so on. So we don't in a lot of places, when machine learning engineers are being hired, then they started with the baseline models, and here I showed up, and the baseline models were already existing. So that's why every day I come to work and I think, man, I'm standing on the shoulder of giants, because that team is just amazing.
That's so cool to hear. I was listening to what you were saying and taking notes in my head. So 3 things. First, structured data in good shape, right? With good tools around it. Second, a good perspective on how to do data processing, because I feel like people, and I really vibe with that, because I think a lot of people, they're like, okay, we can get our data structured for our first iteration, but updating the data, how do you do that, right? And then the third piece is just a team that's educated on these concepts, right? And just knows how to think about it.
Yeah. And I think, to your point, Vishnu, we have the team itself is highly interested in machine learning. And machine learning is not a siloed department at Digits. We work in conjunction with backend engineers, data engineers, front-end engineers, and designers. And I think the connection between machine learning and design is incredibly critical. They usually happen in siloed departments. And so they maybe meet once a year at the holiday party. And that's when some knowledge transfer happens. But in our Digits, we work with designers directly on the team. So when we push out a machine learning model, then we have a conversation with the designers, and it's like, okay, how does it actually affect the design, and vice versa? How does the design affect the model, and how does the model affect the design? And because we had seen this at previous jobs, where I pushed the model out, and that loop was missing, that connecting piece was missing. So we spent months and months and months to train a perfect model, and then it was misunderstood by the UX or by the user, not understanding what the implications of the model are. And they clicked the wrong buttons, and it generated garbage data, and all of a sudden we're like, damn it. And that's sort of in my mind, it's often one of the core pieces why machine learning fails. It's sort of this integration with design, and how do real users interact with that machine learning models? What are the real world consequences once the model shows up? Because any system adapts to changes within the system, and it's the same for machine learning. There's once you start predicting something, people start how can I tweak the system? How can I turn this into my benefits? And the other thing, what I think is what we should talk more about, in the whole MLOps community, I think that the real machine learning happens once the model is trained for the first time. Scaling machine learning models is a big, big deal. And I think we still don't talk enough about that. It's not just about serving a machine learning model, but scaling the usage of the machine learning model. So recently we have a tremendous growth at Digits. We ingest millions of transactions, new transactions every day. This is it's a perfect place for machine learning engineers. It's small. It's we have a really good team, but we have a lot of data, and so we often see interesting things around we have the model deployed. This is all on auto scaling. We can scale those operations, but then also we need to scale our pipelines in conjunction with our machine learning models, and to get the optimal throughput there. That is a really interesting question right now, and there's a lot of learnings on our end of how to scale machine learning, how to get an optimal throughput through the systems after the model is deployed.
I had a quick thought here that I wanted to share. First off, are you guys hiring on the machine learning side? Because this is a running advertisement. For
this is yeah.
It's like a Glassdoor ad, a long 45-minute Glassdoor ad for working at Digits.
Yes, we're hiring. For all positions, front end, back end, data engineering, machine learning, anything.
That's awesome. Okay, cool. All right. Well, everyone, now you know where to hire, and then now you know where to look to get hired. The second thing I want to say is, I think something I've been thinking about in my head has kind of been the evolution of our industry from working on ML models to products to systems, right? And I think, between, 2015 to 17, right? Maybe 18, everything was all about working on fancy models, right? Just putting out a new kind of deep learning model or something like that, right? And now between 2018 and maybe around 2022 or so, like we've started to think a little bit more like, okay, well, what does it take to actually build an ML product, right? And I think we're still thinking about that. And now with some of the integrations with data engineering, some of the changes in data engineering tools themselves and software engineering, like the systems level engineering that you can do, not just a Google and a Facebook can do with oodles and oodles of dollars and engineers, but everybody can do it now, right? And that's what's really exciting to me, is to see that. And like Digits is an example of that.
Absolutely. I think in the machine learning field, we have this struggle right now that a lot of things were hype driven. A lot of things were sort of like marketing driven. It was like, hey, we're an AI company, right? I think just because you produce a machine learning model doesn't make it an AI company. Like you need to get to the systems point of what you just said. Like then I think we can say like, yes, this is an ML driven company, or like we're data driven, or like machine learning powered or something like this. But we have to get to the point of that systems approach. And just training a machine learning model, just deploying this doesn't make it a system. It does make a system when, like in a control systems approach, like typical systems engineering, like you have a black box that gets an input, that gets an output, and then you have a control parameter. And for our machine learning systems, that control parameter is a feedback loop. You need to give your users a way to give you feedback around your machine learning systems at any given point in time. So for example, we have like in the product, we have a tool which is sort of like making recommendations of like, we think this is wrong in your accounting. The users can click on a little button and then see why did we make that suggestion. So we built machine learning explainability right into the product, and it shows you like it's something what you would expect from Sharp or Shape. Sorry, I always mispronounce this tool. Of like why in this particular string, what did our machine learning model fire on? And that is like directly integrated into the product. And if people have a problem with that, they can just click on a little button, we get a notification, and we're going to analyze that particular tool. And we look at all the actions users do based on our recommendations, and that is a feedback loop really critical in all the thinking about MLOps.
So just piggybacking off of that design decision that you took to say, we're going to have explainability built into our machine learning model, I imagine that is because of the conversations that you have with the designers. And I'm wondering if you have any more examples of how conversations with designers has changed the way that you have built machine learning products.
I have to admit, the design team is amazing. Like we have wonderful designers, and they have a very, very strong interest in machine learning. That is the first ingredient to like a really cool collaboration. That the machine learning folks have an interest in design. I think this happens naturally, like just because your eye is like working with you, and you're like whenever you see a new design, there's this automatic appeal to like check it out. And so it's much harder for the design team to have an interest in the machine learning operations and like the use cases of machine learning. But I think that happens automatically for the folks on the team. So that's really great. We never have to drag them in the conversations. They're already like they're part of the decision process and the conversations. In terms of the actual conversations, I think that there's conversations going both ways. Like from the machine learning side, we have conversations around what type of feedback loops do we need to make our machine learning model successful. And then the designers come back and it's like, hey, I think this is how we could integrate this into the product. Like we coined the phrase of like, we have this phrase of a living model, and the design is basically like lifting the covers, and like we give people a sneak peek into the brain of like what's actually happened behind the scenes for this living model. So, and those conversations are going both ways. Like from a ML side, is like this is what we need, and the designers are like, hey, this is what we could provide. But also there's another thing where like, let's say you have an onboarding flow. The designers could come in with questions of like, hey, do we actually need to ask this question during our onboarding, or could we predict it in some way? We might not be always correct, but like, can we make this onboarding flow simpler? And those are sometimes questions we get from the design team, and then sometimes the answer is yes, and sometimes the answer is no. And like it's a really good conversation, and this is something what I've seen in other companies sort of like missing, where the designers are not even aware of like what machine learning can provide to the design itself.
But did you have to do specific like data literacy or machine learning literacy to get them up to speed? Or were they just interested and they started coming to meetings where you all would interact?
It's a little bit
Were
of
they
both.
just interested and
So
they started coming to
we work
meetings
in what we
where
call work
you all
streams,
would
and the work
interact?
stream covers a particular feature. And in this feature, in this work stream, we are paired. A bunch of machine learning folks are paired with a designer and backend and front end engineer. So every time we meet, we get a holistic view a couple times a week. But just on the side note, like I think Digits does some cool things around like how we organize teams and how we work remotely. But on the so in that point, we always have like multiple touch points during the week when we actually get to talk to the designers, and the designers we might talk on the side about like something machine learning related, and the designers are like, hey, wait a second, can we use this in our design? So that happens naturally. But then when we bring up new concepts, like for example, similarity learning, what does it actually mean for the product? Then sometimes we have like in brown bag sessions, and the designers are always part of that, and they would learn about like how does it actually work, and then there's sort of like a natural conversation happens afterwards, of like, ooh, how can we actually use those things in the product? And so those brown bag sessions happen at other companies as well, totally, but they usually just happen within the machine learning team to educate other machine learning engineers, and then they have to wait for the next holiday party to actually convey this message to the design team.
This is so good, man. And it really shows me the power of like that hybrid team layout, and how if you just get the ability for these teams to be able to interact in a nice way together, it's going to create beautiful things. And you're going to see pieces that you, as a machine learning engineer, you're very focused on a subset of problems. And when someone else comes with a different perspective, I'm sure there's been a lot of times where they've opened up your eyes to how you can use something differently, or potentially you're teaching them, and then they come with questions like, could we do this? Like you were talking about with the predicting the onboarding flow. So I love hearing about that. I also, I'm really like, I think that you have stated it so clearly, the importance of like data hygiene, and not just the machine learning level. Like if what you were talking about, that foundational level is not there, it doesn't matter how good of a machine learning team you have, you're not going to be able to go places, because you need that data hygiene on the very, very basis of the whole pyramid or hierarchy of needs, right? So I got one last question for you, man, before we jump off. And it is a little bit of a rapid fire round, we could call it. What was the last book you read? Because I see in the background, there's nothing but O'Reilly books on your bookshelf. So
You only see half of the bookshelf, so there's some non-O'Reilly books there as well.
what was the last one you read though? O'Reilly or not, it doesn't matter.
As a technical book, I think what's currently on the nightstand is like the Atlas of AI. It's a really great introduction about like what are the consequences of machine learning, or in parts you might not have expected, like environmental consequences, for example, labor consequences, like consequences on like politics, democracy. Highly eye-opening book. Like I highly recommend this book. And on the on the fiction side, I carried a book with me for the last 20 years. Just by unpacking a box the other day, I found like a Fury from Salman Rushdie, like before all the news happened. But that's basically on my nightstand as a fiction book right now.
Incredible.
Very nice.
Last one for you. How do you want to be remembered?
Ooh, that's a good one. I would love to, like, I don't know, something around like his jokes were silly, but they were funny. Like they were odd, but funny.
That's something I could get behind. That's that is mine too. Well, Hannes, man, this has been eye-opening, and I appreciate the transparency and the level of just openness that you've been able to get to with us. I love when we're able to pick someone's brain and they tell us everything. You broke down your whole stack. Maybe later on we will create some kind of diagram for the listeners out there and have it like what your stack looks like. And I just think it's fascinating, this idea. There's two huge things that I loved. One was the data hygiene, and the other was like have a baseline model in place before you go and you do your deep learning, like really cool cutting edge stuff. Make sure that you have your basis in check. So this has been awesome. Vishnu, you got any last final thoughts, closing thoughts?
People, go work at Digits, man. Go work at Digits. That's all I got to say.
That's it. We'll leave exactly. We'll leave that careers page for Digits in the description in case anyone wants to go and apply.
It is a good place indeed. And if anybody has questions around the stack and how we solve problems, feel free to reach out. We're happy to answer them. That's another thing about machine learning. I think you can be really open about like what is actually happening behind the scenes, because even then it's hard to replicate the things for folks because you don't have the data. So it's like, and there's a lot of like learnings we can share with other people, and they can apply them to their business problems. Because at the end of the day, we're trying to solve business problems, not like writing fancy papers.
Yes.
And we're happy to share information. So feel free to reach out. Yeah.
Last call to action for everyone listening. Go and check out Hannes's book, Building Machine Learning Pipelines. We will also leave a link to that in the description. That's all we've got for today.
Thank you for having me. That was a blast.